Hello and welcome to another tutorial of Proflan YouTube channel. In this particular video, we're going to go through all the integration techniques you need for your P3 paper. Before you go to do your exam, make sure you know how to perform this kind of integration. We have a set of 10 questions that is going to take you through on all the integration techniques that you are supposed to learn in order to perform P3 examination for CIE A-Level Math. Now we need to go straight to the first one, and we are told that integrate cos cubed x dx. Here we are going to use u substitution. So this is what we have. This is what we have at this given point. We are given question number 1, integrate cos cubed x dx. Remember, on this question here, we cannot be able to say that cos u equals to cos x so that we can be able to perform u substitution here. But we are going to write this. We can be able to express this as integral of cos squared x cos x dx, right? So that we are going to say our u is going to be sine x. So once you have u like that, we can be able to substitute here, but we are going to find now du. Our du is going to be cos x dx, right? So once we have this, we know that anywhere we have cos x dx, we are going to replace that with du, right? So which will mean that our expression here is going to be integral of cos x. So this can be written as u So this is going to be written as, because we are going to express this again, we're going to say integral of cos squared x cos x dx. So this part that we have here, we are going to write it in terms of sine squared. So we're going to say this is going to be written as 1 minus sine squared x cos x dx. So next, now we are going to substitute. Anywhere we have sine, we are going to substitute u. Anywhere we have du, anywhere we have cos x dx, we are going to substitute with du here. So this is going to be, integral of 1 minus u squared du. So at this given point, we can be able to integrate term by term, and this is actually going to be u minus u squared plus 1 over 2 plus 1. Then we are going to say plus c. Now, once you have gotten your integral simplifying to u cubed over 3 plus c, then we are going to replace now the u that we had said. So this is going to be sine x, because our u was actually sine x, and this is going to be minus 1 over 3 sine cubed x, then plus c. Now this becomes the answer in that kind of situation. So let's check number 2. What are we having? Which other techniques do you need in order to do your P3 paper? I'm having integral of 9 over. We're going to have question number 2, integral of 9 over 4x squared plus 1. So in the event you are given this kind of question, you need now to ensure that you are going to take this 9 out, so that we are going to have integral 9 integral of 1 over, and I'm going to factor this 4 out also, so that I'm going to remain with x squared plus 1 over 4 in that case, then with respect to x, right? So this 4, I can be able to bring it out, so that I'll have 9 over 4, right? Integral of 1 over x squared plus 1 over 2 squared with respect to x. You need to remember this kind of question that you learned. So remember, you had learned that if you are integrating integral of 1 over x squared plus a squared with respect to x, when you're integrating that, you said that this is going to be 1 over a tan inverse over x over a, like that, then plus c. And that is actually the technique that we're looking at this in this case. So this one is going to be 9 over 4, and then we're going to multiply by 1 over a, but our a is a half. 1 over a half is going to be 2 tan inverse of x over this is going to be 1 over 2 here plus c. And finally, this is going to reduce to 9 over 2 tan inverse of 2x plus c. And that is exactly what you are supposed to do. An integration that looks like this is the procedure you are going to follow in order to perform that kind of equation. Let's look at number 3. Which techniques do you need in order to work out question number 3? You are supposed to learn how to integrate exponents. Exponents are a question that also they are very, very, very important for you to know how to integrate. So number 3, integration of exponential functions. Now, integration of exponential functions. Suppose you are given a question like this. How are you supposed to integrate that kind of equation? You are told integrate e is to 3x plus 4 dx, and then you have your 5 at this. What are you supposed to do in order to integrate this? Now, integrating exponential function, this is what we're going to do. If you are having this kind of a scenario, we're going to factor the 5 out so that we say we are integrating 3x plus 4 with respect to x. So which will mean that if you integrate this, you are going to get 5 over the differential of this, differentiating the top. What are you going to get? You are going to get 3. So you are going to say 5 over 3, a is to 3x plus 4. That is exactly what you do in order to work out this question. So meaning it's combined with other kind of expressions. If you are having e is to 1 over 4x minus 3 plus ln over x, yeah, you are integrating this with respect to x. What does it mean? You are going to integrate term by term, of course, this part, and this is going to be differentiating the top. You are going to get 1 over 4, and 1 over 4, 1 over 1 over 4, e is to 1 over 4x minus 3, then plus. Integrating this, we are going to get the answer what? So in the event you are given another one that is having maybe 3 is to 1 over 4x minus 5 with respect to x. When you're integrating exponentials, we are going to say that we are going to take 3, of course, out over if you differentiate this part here, you are going to get 1 over 4. So this will be 1 over 4 here. Then e is to 1 over 4x minus 5 then plus c at that given point. So meaning that this is going to translate to 12 e is to 1 over 4 x minus 5 then plus c as the integral. So you need to know how to integrate exponential functions. We need to move to we need to go and now look at how do you integrate a trigonometric functions. How do you integrate trigonometric functions? So you can be able to use U substitution in trigonometric functions, but however, I need to bring to your attention that if you are given a question like so if you are using a trigonometric function like sine 4x dx, integrating sine 4x dx. Now, how do you perform this? Remember, if you integrate sine x is, but if you are having a number here, a variable here, 4x, you are going to say 1 over 4, because if you differentiate this, you are going to get 4. So you are going to say 1 over 4 of this. You are getting it from this point. And then you now integrate the sign itself. So this is going to be negative cos 4x then plus c. So finally, we're going to have negative 1 over 4 cos 4x then plus c. Because of that, ensure that when you are having a function here on this trigonometric function, you are going to differentiate it, divide it like that. In the event you are given tan squared 5x, powers of trigonometric functions, powers in trig functions. Powers in trig functions, you are going to approach it in two ways. You can be able to use Pythagoras identities, or you can be able to use double angle. For instance, if you are given integral of cos, so remember that cos 2a is equals to 2 cos squared a minus 1. So meaning we need to reduce this power so that we have it as double angle. So meaning that we can be able to express this, our trigonometric function here, in double angle. So we are going to write here as 2 cos squared a, but our a is here, which is going to be 3x. On this other side, we're going to have cos over 2 times a. Our a was that, so this becomes, meaning that if we are having this expression here, we can be able to rearrange it and say this is going to be cos squared 3x is the same as cos 6x plus 1 then over 2 like that. So meaning this expression that we have here can be able to be replaced with this. So once you have done that, we can be able to say now our integral of that is going to be 1 over 2 cos 6x plus 1 over 2 with respect to x. Then we're going to integrate term by term, and we can factor this half out. So we are going to say 1 over 2, right? Cos 6x dx, integral of 1 over 2 with respect to x. Now, if we integrate this, we are going to say you are going to differentiate this function you have here, which will mean that this is going to be 6, and then our answer is going to be 1 over 2 over 6, right? Integrating cos is actually sine 6x, then plus 1 over 2x plus c, like that. Integrating this, we're going to get 1 over 2x, then plus c, like that. So which means that if we simplify this, we are going to get our answer sine 6x plus 1 over 2x plus c. So anytime you have powers on sine, you have cosine powers on cosine, sine and cosine, you need to use double angle in order to reduce it like that, so that you can be able to perform the integration. Still in trigonometric functions, you may be in a scenario whereby you need to perform an integration. To perform this, you are going to sort the help of Pythagoras identities. So remember, 1 plus tan squared A is equals to sec squared A. So which means that we can be able to express this tan to sec, because in our MF19 we have how we cannot be able to, we don't have the technique to integrate tan squared, but we can be able to integrate sec squared. So which will mean that this one we can now say 1 plus tan squared 3x is equals to sec squared 3x, because our A is actually this particular part. So meaning this term can be written as sec squared 3x minus 1 with respect to x, like that. So which will mean if we are working out this thing, is going to be integrating this, we are going to get tan, integrating this, remember we have this 3x here, so we're going to say differentiating this, we're going to get 1 over 3. But integrating sec squared, we are going to get tan. So we are going to get a third tan 3x, then minus x plus c, like that. So to integrate, of course, if you're having the limits, you can be able to put them in so that you can be able to proceed. Another integration technique you need is whereby you have a function like this. If you are told to integrate a function that is like this, you are having 8 over square root of 5x minus 5